In this video I'm going to look at a combination of transformations for the parabola, and in particular I'm going to show you turning point form, which you may or may not be familiar with. So I'm just going to draw the general equations for a parabola in turning point form. Now A, H and K are all constant values. Now if we have a look at what kind of transformations have occurred from a basic graph of y equals x squared, we can see that there has been a dilation factor. Remember, anything that's a dilation factor is in the form of a f of x. So we can see there is an a in front of the x squared part. We can also see that there is a horizontal shift because it's in the bracket. Now in this particular instance, some textbooks will write plus h, some will write minus h. What you need to be aware is it's always the opposite sign. So for example, if you've got x minus 2 squared, that means it has moved in the positive direction 2 units. You can see there's a plus k on the end. Oh, hang on, let me just write the general form, remember, for a horizontal shift. It's something in the form of f of x plus c or h. Remember, that's just a constant. And when we've got something in the form of f of x plus k or plus c, it means there's been a vertical shift, and we can see there's a vertical shift. Now what turning point shows us, turning point form, it shows us a combination of these three transformations. A being the dilation factor, H being that horizontal shift, and K being that vertical shift. So I'm going to do a couple of examples where we have a look at if we can identify what kind of combination of transformations have happened from the graph y equals x squared to a function. So in this particular equation we can see that from the graph y equals x squared, this graph has had a dilation factor of 2. Remember, that means the graph has gotten thinner. It's had a horizontal shift of plus 3, which means it's gone backwards minus 3 in the negative direction, because remember we need to change that sign. And minus 4 tells us the vertical shift, so the graph has gone down. So those three combined transformations means that our turning point will move. So the turning point is sitting at negative 3, negative 4. So negative 3, negative 4 is like that. So it's here, okay, on the plate, and looks like that. Now in order to draw a proper sketch, you should always have key features such as where does it cut the x-axis, where does it cut the y-axis, and what's the coordinate of this turning point. I'm going to show you how to do that later on in a second video. Let's have a look at trying to identify some more combinations of transformations. So I'm just going to draw up this equation here. So this is y equals bracket 2x minus 1 squared plus 8. And what we can identify here is that this isn't quite in turning point form, because there is a number, a coefficient in front of the x. And in order to show a horizontal transformation, we need to have the value of x, or the coefficient of x, as 1. So the first thing I need to do is remove the 2, or take it out of the bracket. So in order to do that, I need to remember that it's 2 squared that I'm actually removing from the bracket. So I'll kind of just show you, if I'm taking out the 2 squared, I'll just show you that. We've got x minus. Now when I take a 2 out, I'm actually going to have to divide this number by 2 as well. So I get that. Like that, and it's plus 8. Now, work that out. You get, and you don't have to have the square brackets. I'm just trying to purely show that that's still this bit here. And simplifying that gives us 4 bracket x minus 1/2 squared plus 8. And we can clearly see there's been a dilation factor of 4, so the graph from x squared has gotten thinner by a scale factor of 4. Horizontal shift tells us it's gone in the positive direction of half a unit, because remember we changed the sign. And then the vertical shift has gone up by 8 units.